Welcome back to another video of this summer lessons. In this video we are going to use different methods to find GCF. In the first question we are asked to find GCF of 20 and 30. In the second we are asked to find 16 and 24. And in the third we are asked of finding GCF of 36 and 60. Now you can use any method you like. If you do want to try it by yourself, do pause the video. Assuming that you have paused the video and tried it yourself, now let's see the solution. So for the first question, I am going to use prime factorization method. So in that method, first you break down 20 into prime factors. So 20, as you know, is nothing but 2 times 10, and 2 is 10 is 2 times 5. So 20 is 2 times 2 times 5. Next we find the prime factors of 30. So similarly you do 30 is 2 times 15, and 15 is 3 times 5. So you see it's 2 times 3 times 5. Now to find the GCF, all you have to do is find the common factors from the two, and you'll say 2 and 5 are common. So count it only once if it's common, and you'll say it's 2 times 5, which is 10. So the GCF of 20 and 30 is 10. Now next question, we are asked to find GCF of 16 and 24. Now in this for this I will use again the prime factorization method. We know 16 is 2 times 8, 8 is 2 times 4, 4 is 2 times 2. So if you write 16 as a prime factor, 2 times 2 times 2 times 2, then 24 is 2 times 12, and 12 is 2 times 6, 6 is 2 times 3. So 24 in terms of prime factor would be 2 times 2 times 2 times 3. Now compare the two prime factors, and you see the 2 repeats 3 times. So if you are asked to find the GCF would be the common ones. So 2 is repeating 3 times in both the factors, so you write 2 times 2 times 2, and it is 8. So the GCF of 16 and 24 is 8. Now moving on to the final question, finding GCF of 36 and 60. For this question I am going to use the division method. So the division method, all you have to do is list the two numbers on the right hand side, then divide it by prime numbers starting from 2. I'll first try to divide both numbers by 2. As you can see, 36 and 60 are both even numbers, so we can divide it by 2. So when you divide it by 2, 36 will become 18, 60 will be 30. Again, both numbers are even, so you can divide it by 2. This will become 9, and this will become 15. Now both numbers are odd, so we cannot divide it by 2. So we'll move on to the next prime number, which is 3. So does 3 divide 9 and 15? So 3 times 3 is 9, and 3 times 5 is 15, so yes. And then we are left with 3 and 5, which are both prime numbers. So at this point there is no prime number that can divide both 3 and 5. So we stop at this point here, and the GCF would be just the number on the sides on the left column, which is 2 times 2 times 3. So 2 times 2 is 4 times 3 is 12. So the GCF of 36 and 60 is 12. So that is how you find GCF using prime factorization and division method. Now I know I haven't used the first method, which is listing factors. The main reason here that I didn't use listing factor is because the number here are relatively large numbers. So for large numbers, it's always better to use prime factorization or division method because it's much easier and less time consuming. So that is why I used these two methods. Although you're free to use any method. This is it for how to find GCF. If you have any questions, let me know in the comment section below. I'll see you in the next video.